Okay, so one of the big payoffs to this theory is that we can actually do some curve fitting. We can find a polynomial function that has certain zeros by just taking advantage of what we learned here. So for example, in this first one, we want to find a polynomial that fits the data that's given. So 1, we have a picture, and 2, we have some language. And what we're told in part A is that our polynomial p of x has zeros at -3, 2, and 5. So what that means are a couple of things. In terms of our polynomial, this means that p of -3 is equal to 0, p of 2 is equal to 0, and p of 5 is equal to 0, right? So that's one thing we can tell from that. But that doesn't help me build the polynomial I'm trying to find, right? Because we're trying to create a polynomial that fits the data. So this is all true, but it doesn't help me. What also do we know? We know that -3, 0, and we know that 2, 0, and we know that 5, 0. These are all x-intercepts of this graph. So if I was to graph this polynomial, we know that it's crossing at -2, 0, at -3, 0, at +2, 0, and 5, 0. So it can be doing all kinds of things, but it's got to be crossing the x-axis at those 3 locations. But again, that doesn't really help me find the polynomial because I just can visually see where it's crossing the x-axis. But here's the big guy, right? X minus c is a linear factor of the polynomial. So -3, right, that would mean x minus -3, which gives us x plus 3 is a factor. X minus 2 is a factor, and x minus 5 is a factor. So how do I build this polynomial? Well, if these are factors, that means my polynomial is a product of these 3 factors. Alright, oops, I think that should be a 2 right there. And so I have just guaranteed that this polynomial, right, when we throw -3 in there, this part's 0, so everybody's 0. When I plug a 2 in here, this part's 0, so everybody's 0. And when I plug a 5 in here, this part's 0, so everybody's 0. So I've guaranteed that's happening. And of course, if I guarantee that this is happening, then visually I have those x-intercepts happening. Okay? And then last but not least for this particular one, we know that whether I stretch the graph or compress the graph, that this combination of factors will continue to have these corresponding x-intercepts. So there's actually an infinite number of answers to this by just letting a be your favorite number. Let it be 1, so it's nice and simple. Let it be 2, so it's kind of stretched out a little bit. Let it equal to 1/3, so it's kind of compressed. But no matter what, this graph is going to basically be going through these 3 points. And if I may, right, what I could also do is if we were to multiply these together, right, eventually we're going to have an x times an x times an x. So this is an x cubed. So we're either going to be generally increasing or generally decreasing. And so now I can actually start sketching this graph. So maybe here's a potential sketch of this particular function, right? Here what I'm doing is I'm assuming that a is positive because I'm generally on the way up. So you can start to see where we can actually start to graph this function once we actually have the function that we've built. Alright, and it's all based on this theory that if I have a 0, I have an x-intercept, and more importantly in this case I have a linear factor. So let's go do B. So B, the picture's given to us, so what I can see are x-intercepts, right? And in this case I have 4 of them. So this looks like it's at x equals -6. That looks like x equals -2, right? X equals 1, and x equals 3, right? And I guess those are the zeros because we can see that -6, 0 is the x-intercept, -2, 0 is the y-intercept, -2, 0 is another x-intercept, 1, 0 is another x-intercept, and 3, 0 is yet another. Alright, so because we have this, we now know that these guys are zeros. Of course, how do I build this function? Well, they all have factors, right? So x minus -6 is a factor, so x plus 6. X minus -2 is a factor, so x plus 2. X minus 1 is a factor, and x minus 3 is a factor. So this function is sum a x plus 6, x plus 2, x minus 1, and x minus 3. And related to our theory, if we were to multiply this all out, we're going to have an x times an x times an x times an x. We're eventually going to get x to the 4th out of this, plus a bunch of other stuff, but we're definitely going to get x to the 4th. And this behaves like a degree 4 polynomial. And we also know that our a has to be negative. Alright, so we've got that as well. Alright, and so there's our function. Of course, we can do this rather than being a general one like we did over in A. We can actually be a little bit more specific in B, because I can use some data points, like how about right there, 0, negative 2 is the y-intercept. So if I plug that in there, right, that means that A, 0 plus 6, 0 plus 2, 0 minus 1, and 0 minus 3, this all has to equal negative 2. And just like we did for our quadratics, I now can actually find the A that makes us fit this data perfectly. Alright, so general versus being specific. So let's do the math here. 6 times 2 is 12. That's a 3. So we're going to get a 36a equals negative 2. Divide both sides by 36. And our a is a negative 1/18. Which doesn't surprise me, right? Because we were expecting a negative a. So what's the function that fits this picture? Our p of x is negative 1/18, x plus 6, x plus 2, x minus 1, and x minus 3. So we are starting to do some curve fitting based off of the theory. So if I have a 0 or I have an intercept, I have a factor. If I have a factor, I've got an x-intercept, I've got a 0. So which one we need just depends. And here we were asking for us to build a polynomial, so I eventually needed the factors. I needed this piece to help me build the function. Okay, so there's that. There's obviously some more payoffs that we'll do in the future, but that should get us started. We're almost 8 minutes into this, so I'm going to pause, and we're going to talk about multiplicity in a new video. Right? We'll bust out our calculators and do it that way. But let's cut away for that topic in a new, fresher breath, if you would. See you in the next video.